right, I'm going to kind of start on the right-sided ones where we can practice putting it into the exponential form and logarithmic form before we get into the solving one. So this is where we're going to use our, I need to get my little glove thing because my fingers keep sticking to the screen. So we're going to use our BPA log BAP thing that we did yesterday. Ooh, chunky pen. BPA is the same thing as log base B of A equals P. This thing, we're switching things around, putting them in other forms, playing with these like Play-Doh. There it is. I found it. The music that's coming from here. Rude. So if you've got sound on, turn it off. I can hear it up here. Super rude. All right, so switching this into, for this first one over here, into exponential form. For over here, what's our base? 3. What's our exponent? 5. And the argument that it equals is going to be 243. Ooh, hello. There we go, 243. So the second one down here is the same kind of vibe. We're going to switch it around. Log base what? Down here. What's our base going to be? 2. Yes. Of what? 512. Equals what? 9. So on this one on the left-hand side, we don't know what it equals. So we're going to pick like a variable for it to be. I'm going to use X because it can. You can use Y. You can use Z. You can use heart. You can use happy face. I don't care. And what we're going to do is we're going to switch this into exponential form to try and figure out what this is. So we're going to take our base, which is 4. Our power is going to be that X. So we want to know 4 to the what equals our argument of 8. And now we want to solve this. Think about our exponentials, how we would solve them like this. What can I do to be able to figure out what the X is in that exponent? We need to get them to have the same what? The same base. So what would be a good choice for a same base on these? 2. How can I write 4 in terms of 2? 2 what? What exponent could I put on a 2 that would give me 4? 2. 2 squared. So 4 to the X is really 2 squared to the X. How about 8? What could I write that with a base 2? 2 to the what is 8? Not 4. 2 to the 3rd. 2 times 2 times 2. So now we're into solving. This is firmly into last chapter stuff right here. What do we do with our exponents? Down here? What do we do with these exponents? 2 to the what? On the left-hand side. 2 to the 2x equals 2 to the 3rd. Now what? My bases are no longer relevant. So we get that 2x equals 3. What does x equal? 3. It's like, what do we do to get the 3 by itself? Divide by what? Divide by 2. So we have x is 3/2. So there are questions that are worded like this on the homework up here. Just put this number in on McGraw-Hill. Just the number. We need to add the x and do all this stuff to solve the equation, but you're just going to put what this equals in on the homework question. Okay, because a couple of people have problems with that yesterday. Questions on these? Okay. We're going to finish out 8-1, but I kind of hated the way the book was doing it. So that's why you have a little worksheet that you picked up. I'm going to pass out as many pages as we can get to today because there's like 2 more sides of it. I did it single-sided so that you could glue it into your books. That way we won't lose it. But, you know, all that jazz. So what we're going to do is we're going to be working on graphing these. We're going to start with graphing logs today. And this whole thing, the easiest way to graph a log is to remember what we kind of figured out yesterday, that this undoes those exponentials. It's that inverse operation where I take my x and my y and we switch their places. So what we're going to do is we are going to use exponentials to graph logarithms, which we've done exponentials for a hot minute. So what we're going to do first is we are going to graph an exponential parent function of 2 to the x. That's where we pick our x's to find our y's. And if we don't have an h or anything on there, what do we pick for our x's? What do we usually use? 0, 1, and 2 are good, but also -1 and -2. When we put those into our exponential function here, 2 to the x, that's when we get things like 2 to the 0 is 1, 2 to the first is 2, and 2 squared is 4. 2 to the -1 is 1/2, and 2 to the -2 is 1/4. You can type those in your calculator. Hopefully we can start maybe doing some of those in our head. Those are things we've done before. And we're going to graph that. I'm going to graph that. So -2 has a point at 1/4. -1 has a point at 1/2. 0, 1. Sorry. 1, 2, 2, 4. If you want to keep going, you can. 2 to the 3rd would be 8. And that's all we got space for there. So we wind up with something that looks kind of like this. Remember, we have that asymptote. It's going to be stuck against that 0 wall there. So I want us to think about, I don't know why I did that. When we make our inverse, we did this yesterday, we took our x and our y and we made them change places, right? Like that's how we make the inverse. To make an inverse graph, we're going to take what was the x columns and put it in the y. -2, -1, 0, 1, 2. We're going to take what was the y column, and it's going to become my x's. 1/4, 1/2, 1, 2, 4. So we don't have to do any actual calculations on logs. We're going to take what we know about exponentials, pick up the columns, and change their places. That's all we do with that. And that is the table for a logarithm. Our x is 1/4, which gives us a y of -2, which I'm going to zoom this in a little bit here, which is down here somewhere. My 1/2 is at -1, 1, 0, 2, 1, and 4, 2. So green, the green graph over here, this is a log. This is log base 2. This purple is 2 to the x. They are inverse operations. Does the green graph still have an asymptote? Yes. Is it a horizontal asymptote? No. It is now has a vertical one. We've got like a little, oh, that's purple. I'm not doing purple. There we go. We get a vertical asymptote right there. And we'll talk more about asymptotes in a minute. I'm not going to graph it when we have a log on the page because it gets really, really confusing. But I wanted us to notice that the asymptote has changed directions. But other than that, it's exactly the same information. So now we're going to do another one of these. We're going to do 4 to the x to find log base 4. Again, when we are writing our parent table, we are picking our x values. Usually we do -2, -1, 0, 1, and 2. That is not a law. That is just easiest. Like that's not a you have to do it for the math. That's a this is probably your easiest option. And we substitute those into our 4 to the x. Anything raised to the 0 power is 1. 4 to the first is 4, and 4 squared is 16. I tend to do my positive numbers first because it lets me kind of get into the vibe. But you can fill in your tables however you choose. So 4 to the negative first, that's 1/4. And 4 to the -2, that's 1/16. It's always going to wind up being 1 over these numbers here, the first and second. So to graph our log base 4, what we're going to do is I'm going to grab my x columns and put it in my y column. -2, -1, 0, 1, and 2. I'm going to grab what was the y column, which my stylus is being a jerk today, and it's going to be my x's. 1/16, 1/4, 1, 4, and 16. And then we're going to graph that. My x is 1/16, my y is -2. We're estimating there because I cannot get specific enough to mark against a 16th versus a quarter. -1 is at a quarter. It's going to be just about the exact same place. 1, 0. 4, 1. And 16, which is just off the edge of our graph here, 2. We can kind of eyeball it if it's 1 or 2 squares off the edge of the graph, but if it's more than that, just remember. And we're going to connect those guys up. Questions on that part of the graph creation? Okay, so now we're gonna look and we're gonna find out where our vertical asymptote is, which I'm gonna do in pink. We're gonna have a vertical line. Where is the vertical line that my purple graph can't cross? Where is it? Where do I have to put my yardstick? Nope, I don't want that. To be a wall that it can't go through. Right about there, right? It's right on that axis. So we have to put these in terms of a line. And a vertical line we put as x equals. So right here, which I'm actually going to use the chunkier marker. We typically do it as kind of a dashed line. There we go. Our asymptote, we're going to put it as x equals 0. Just like on exponentials, our horizontal asymptote was y equals 0. On the parent functions, it's going to be x equals. What is our domain? Which x values work? Are you seriously doing another homework right now? Josh. Like, you sit in front row. Don't do the homework right now. So what x values work? For my purple graph. So for our logarithms, for these guys here. Which x values work? Yep, 4 works. X value 4 totally works. These ones, these ones, these ones, these ones. How can I say everything over here? My x's have to be what? Or what's the smallest my x's can be? Can I have an x of 1? Can I have an x of 1/2? Can I have an x of 1/470,000th? Can I have an x of 0? Remember, that's where our asymptote is. We can't quite get all the way to 0, but it can get real, real close. So x has to be greater than 0. It's like if you are in interval notation, that would be our 0 to infinity, parentheses on both. How about our range? What y values work? -2 does work. Is that the only one that works? -4, -6. It's going to be all of them. Yeah, because I can keep going negative. I've got arrows going this way. It's going negative. And this looks like it's going really, really far sideways, but it is also going up. It's just going up real, real slow. So it will eventually get all the way up there. So our range is all real numbers, or negative infinity to positive infinity. Okay, So we are going to start looking at transformations and how to do our A, H, and K stuff. In your book, it does actually have a little bit of this there. Pass these back. This is where we're going to do it. This book is really how to write this. So we've got a transformation force, A, H, and K. A, H, and K still have the exact same jobs they've had for forever. A does our reflection, and it does our stretch or compress. H is our horizontal transformation, scooch left and right. K is our vertical transformation, up and down. Same jobs. Page 401 has this table on there, but we're going to work on that worksheet. So there's a few pages where you can glue those pages if you don't want to have them loose. So this we just kind of talked through right here. We talked about exponentials of functions a lot and how exponential functions had a domain of all real numbers and a range of whatever to infinity, whatever our K was, that transformation form. Since logarithms are the inverse, what was X becomes my Y. What was Y becomes my X. So you can do this without ever having to do logarithm stuff by knowing our exponentials well. So our domain of is going to be H to infinity, and our range is going to be all real numbers. And our asymptote, Y becomes X, K becomes H. So our asymptotes are going to be based on our horizontal shift, the right or left. If you think about that vertical line, it's going to move right or left. So this guy is going to be the boss of the asymptote this time around. So we're going to look at this, and we are going to try and graph this one. So we're going to start with graphing the parent function of the log. We do that by finding this base. Our base is 3 to the x. So when we look at these little tables down here, I'm going to make another one. This one is going to be my 3 to the x. This is where we're picking our x's to find our y's. Just like we did before, we're going to use those same 5 centermost values, -2, -1, 0, 1, and 2. And we get our y's. 3 to the 0 is 1, 3 to the first is 3, and 3 squared is 9, which gives us our negative values of 1/3 and 1/9. We are not graphing the 3 to the x. If you can do the straight into the logarithmic table, you do not have to do the 3 to the x table. But especially for our first couple ones, I recommend it. So we're going to do our log table over here. That's where I'm going to take what was my y's, and they're going to become my x's. 1/9, 1/3, 1, 3, and 9. And we're going to take what was my x's, and it's going to become my y's. -2, -1, 0, 1, and 2. Bless. Oh, somebody in the hallway. And we are actually going to graph our log here. So we are going to put the log on here so that we can see what happens with the transformations. So we're going to have our x's 1/9, y is -2. I'm going to do my parent function in black. 3, 1, and 9, 2. So that is our parent function. We just graphed our parent function. So what we're going to do now, I'm going to move this up there. There we go. Is I want us to look at our transformation form. Our log base b, whatever it is. X minus h plus k. What is our h value? -4, which means which direction is it moving? Left 4. How about our k value? Is -5. What happens there? Down 5. That means from that we can find our asymptote for our transformation function. We know that it's going to be x equals h, -4. I'm going to draw my asymptote in before I try and do any transformations here. So my asymptote is going to be here. I'm going to do it dashed instead of solid because I'm going to plan ahead. So we're going to go here. My asymptote's going to be like that. To find our transform function, what we're going to do is we are going to go to our table. And we are going to do, give me your pen. We're going to do x plus h. And we are going to take what was the x values over here, and we're just going to add h into this column. So we're going to take 1/9 plus -4, or 1/9 minus 4. And that is going to give us -3 and 8/9. 1/3 plus -4 gives us -3 and 2/3. 1 plus -4 gives us -3. 3 plus -4 gives us -1. And 9 plus -4 gives us 5. So we straight up take these values and add h. For the y values, we have to do a little bit more because we're going to go y times whatever the a value is plus our k value. In this one, we don't have an a value because we want to kind of start you off easy. But I know we're a little close to the end of our time, so I want to make sure we introduce that. So it's just, we're going to take these y values here. We're going to go times a plus k. In this case, our a is 1, so we're just going to take our -2 plus -5. So -2 plus -5 is -7. -1 plus -5 is -6. 0 plus -5 is -5. 1 plus -5 is -4. And 2 plus -5 is -3. And this table here is our transformed function. So all we have to do is graph that. -3 and a bit, -7. -3 and a bit, -6. -3 right on it at -5, -1 at -4, and 5 at -3. Remember not to go through your asymptote. It's going to look kind of like that. So our transformed domain and range, I want to know that. What is the domain of our green function? Which x values work? Or where do they stop working? What's the very, very smallest my x is trying to be here? What's my edge of the green line? -4. Can it equal -4? Or just get real close? Real close. So we're going to put a parenthesis on it, not a bracket. What's the biggest it can be, x, y's? Infinity. -4 to infinity. Or you can say x has to be greater than -4. Both of those are entirely valid. You don't have to put both. How about our range? What are our y values? All real numbers. Or -infinity to a positive infinity. And I just switched the order on those. So we're going to switch that. Okay. -infinity to positive infinity. Or all reals. Because this guy does have an arrow on the bottom. I just didn't. Okay. I know that these things are kind of new, the x plus h and y, a plus k, but they will work absolutely every time. Okay? So, we are really close to the end of the period, and I don't want to hand you out another page to do. But that's enough information to get you finished up on the homework here. There's 4 more questions. If you're doing them on paper, these 2 are graphing, and these 2 are identifying A, H, and K. I believe if you're doing it on McGraw-Hill, these have turned into 4 multiple choice questions. Okay, so let me know if you guys have questions. We will continue to practice this kind of stuff. But I'd rather you guys have a little bit of time to work and ask questions than for me to do another one. Alrighty, so let me know if you have any questions. Happy Wednesday.